Okay, so hi everyone, welcome.
Hello.
Can you hear us yet, right? Okay. So this is fantastic attacks and how Kalipso can find them.
Hi, I'm Babayeva.
And Sebastian Garcia. We are from the Stratosphere Laboratory in the Czech Technical University in Prague. I'm the director of the Stratosphere Laboratory and also the ABAS laboratory there, where we are doing a lot of machine learning detection for network security. You already saw the talk of Jan and Frankie about our work in civil sphere, protecting the civil society. We have other projects in there like IoT laboratories, a lot of network detection, a lot of projects to protect others. And we are going to be talking here about our free software intrusion prevention system that is called Sleeps and Kalipso, its interface. So, oh wait, it's on there. Wait, connect? No? Well, let me connect. If I'm not connecting, it's not working. Usually it's like that. Okay, so how many people here in the room is analyzing network traffic as a living, let's say? Network traffic, not as a living, but they go, another one network traffic. Yeah, there you go. Yeah, something maybe like half network traffic. So if you are doing this, usually you will see that the more traffic you have, the more difficult it gets, right? If you remember the talk about Jan and Frankie, they were saying, hey, usually this is a huge amount of traffic. Like one of your computers in one day can generate from 8 gigabytes to 10 gigabytes. So if you have to go packet by packet to that, this is very, very hard. Impossible if you have a network like, imagine here the university network, right? So this is a huge problem, and this is why most of the people go now in the business into machine learning. Not because we like machine learning, but not because of that. It's because you have such amount of data and such small amount of time that you need automatization. So if you have this problem, how would you solve it, right? It's super hard to find infections. And for this, we're going to show you a demo. So that's what I'm going to do. Can you see? Let me see this one. Can you see that? Can you see that a little bit more? So in here, there, yes, no, kind of. Okay. So in here, we are going to show you. Maybe better. The tool is called Sleeps, and we are putting here some configuration file. And we are saying capital G, that is for the interface Kalipso, and then we are just reading a pickup file. Sleeps can read pickup file, interfaces, Argus log, Suricata flow, NFLAG flow, and a lot of different flows, Bro and Zeek flows. And we are going to be running this now. So this is a real infection in an Android phone that was working for some time. And here you will see that, oh yeah, that is the interface starting. So there's going to be something in the background, and then you're going to be jumping here into the Kalipso interface.
Okay, this is a generic dashboard. Hello window, you press tab. And our sleep is running on the background, and to load the data in our interface, we press O. Can you make it small?
Yes.
And on the right, we can see public and local IPs. So we know that we want to look at the traffic of our phone, so we look at the local IP, 10.8, 117. So we click on it, and we can see several time windows. This is the time windows where our profile can be located. So for example, we click on the first time window, and on the left, we can see the timeline. So we can see different requests, for example, DNS requests to Google, and this is a flow from the Zeek, from the conf file, and then we can see the interpretation, the domain name, class, query type, everything. So when you scroll down through our timeline, we can see requests, HTTPS, DNS, and we can see first red-highlighted text that catches our attention, and it's a not recognized established flow from our IP to a destination IP, and you can see that there is a strange port here, 28866, and we are suspicious about that. So we want to know more about this IP, about this port. And if you click enter in the upper widget, you can see that this IP is from Indonesia, and you can see the VirusTotal information analysis, but it says that our IP is okay. But we don't believe that. We continue looking at the data. So we use one of our widgets. This is when our computer acts as a client, and we can see the amount of data sent to a destination port. In our case, we're looking at 28866, and it's TCP protocol, and we can see on the left that it has the biggest amount of data sent. This is a logarithmic scale. We continue further. We press N, and it's another widget, and it says the amount of connections to this IP in this port. We're looking again to the 866, the biggest amount of connection. And then we can press H. H shows us their information about the IP, and as we saw before, it was from Indonesia. VirusTotal is okay, but also we have a string on the right, this one, and this string was created for sleeps, right? And we will talk about it later, but we know that those letters said that this is this connection has a strong periodicity, that we connected to it a lot of time with a specific period.
Yeah, the command and control channel, right? So here, Kalipso is helping us find this information very fast. This is a lot of information. Each of those flows is a huge amount of traffic, but you can jump into that and analyzing the destination ports, the histogram, the source ports, the IP addresses, and the behavioral letters. Kalipso can see very fast what's going on in the traffic, right? So I think that's it, right? So what's going on here exactly, right?
So with our interface, we look at 4 main characteristics, and the first one was red alerts. This is red highlighted text that we saw in the timeline that catches our attention to check this port. The next one was destination port. Destination port. We saw that the amount of data sent to this port was the biggest one. This was also strange. Then the behavior letters, we saw that the connection has a strong periodicity, and the amount of connection to this IP was large compared to others.
So we have this information already, and now we want to see what's going on behind the scenes, right? So this is very fast, how you can use it. You have a pickup of your own traffic right now. You go, you use it, you can see all the graphs, detect very fast if there is something weird or not. Now let's gonna see how this is working. So Sleeps is the Stratosphere Linux IPS, and it's a huge system running here at the backend, which several main ideas. So as a general rule, it's a machine learning detection in the network. We are using behavior to do this detection, right? But how we are doing it? The first concept here is the concept of profiles. So we are analyzing the traffic and creating a complete behavioral profile of each IP address in the network, okay? How do we choose the profiles? Well, for that we have the home network. If you are using here Snort or Suricata or this type of IPSs, you are familiar with the concept of home network. Well, this is different. We are using the home network to pick which IP addresses we are going to be analyzing and creating profiles, okay? So now you have your home network, the ones you want to protect, then you have the profiles of these computers you want to analyze, and inside each profile we'll separate everything in time windows, which means that we are splitting all the traffic in 5 minutes, 1 hour, 2 hours, or whatever you are going to pick. Do you know why we are separating the traffic and doing the analysis in time windows? Do you know why we are not just analyzing all the traffic all together in, I don't know, 1 week or a month of traffic? No one knows? Why? No? If you're analyzing a computer and you see that there is something weird, you will say, oh, maybe this computer is infected. But what about the other day, the next day? What about the previous day? What about in a year? Is it still infected? Well, of course not. At some moment, the behavior changes. The computer that is infected today may be not infected tomorrow. So we need time windows to be able to take decisions in each of them. It's like, well, in this hour, you look like you're infected, but maybe in the next hour, you are not anymore. Who knows? Or maybe you are still are, right? So the detections here of time windows is critical to have real time, but also adapt in time. Ideally, we should be able to see that you are normal, and then that you are infected, and then that you are not infected anymore if, for example, if somebody cleans your computer, okay? A lot of these concepts are later going on into the algorithms, like anomaly detections and stuff that we are going to be doing. So we have the time windows in there, the home network, we have the profiles. Now we need the directionality. So the directionality is, are we going to be analyzing the traffic that is going out of your computer, or also the traffic that is going inside your computer? So these are the two modes of operation. And finally, everything sleeps, or most of the time sleeps, is designed and coded as modules. So each module is completely independent. It's a process that is running alone, and it's sharing the database with the rest of the processes. So the idea here is that in parallel, we are acquiring all the information possible. It's like from your protocol, from your ASM, from your geolocation, everything at the same time to speed up the process, okay? So, about the modules, we have some modules already here. There are more coming, in particular the threat intelligence module that is downloading threat intelligence feeds from the internet and matching each IP address against them. So this is done in the background, and you can put your own feeds in there, you can put your own IPs. Now we have there our own stratosphere feeds of blacklist of IPs that we are collecting from our honeypots. So we have like a lot of honeypots in the university and malicious traffic, and we are putting all this in a feed that is being downloaded into Sleeps right now. The second one is the ASM, the autonomous system name or number. We go there and find which is the organization that is registered in your IP. Then we have Kalipso itself, it's running as a module. Then we have the GeoIPs to know where are you in the world. And then we have the port scan detection. This is a very complex module that is detecting horizontal port scan and vertical port scan in time. In flows, not packets, so this is kind of different from the rest of the port scanners detectors, like in Snort and in Suricata. Then we have the timeline. This is a module that is taking the complete the Zeek logs and is trying to merge all the logs together. So Zeek usually is giving you files with DNS, HTTP, HTTPS, or SSH, Telnet, but now we are putting them all together and making the timeline. So we want to know what your computer was doing in sequence. Oh, you went to Google, and then after that, I expect you to go to a web page. And after the web page, I expect you to go to another web page, right? I'm not expecting you sending 3,000 DNS requests without any connection after, right? So you can start playing with this concept with this module. And then we have the VirusTotal module developed by Dita Holmanova, and she's taking the information from VirusTotal. You can put your own API key and enriching what we know about this IP in real time from VirusTotal. We're going to show more later. And then we have the Whois module, also done by Dita, where of course is taking the information from the Whois. A very difficult thing if you ever analyze Whois structured data, very, very hard. There are two more modules that are coming soon. They are ready, but we are still merging. One is the anomaly detection module, and the other one is the machine learning command and control detection. We have two different methods in there. These are coming soon to enrich all the information. And of course, something more we are working is how to take all this information together and try to ensemble this into one final decision. This is being done now by Paula in Argentina, and she's working on how we can take all these decisions from different sources, VirusTotal, threat intelligence, in time, and take one final decision if you're infected or not. Very hard work also. So after this, I want to tell you something more about the directionality process. The directionality works like this. Imagine you have two computers, A and B. And A is connecting to B, and B is connecting to A, okay? So, if you are having no home network, it means that you are going to be creating one profile per IP, one profile for A, one profile per B. And then since the mod is all the traffic, I'm going to be putting in the profile A, hey, you have a connection to B, and also you have a connection from B. This is in this profile. And in this profile, I'm going to say, hey, you have a connection from A, and you are connecting to A, okay? Now, look at the difference when we are having the home network defined. So now when my home network is A, I only create this profile and I have 2B and from B, but there is nothing about B in any profile, okay? And if I have here the modality out, not all but out with no home network, then I only care the stuff that is going out from you, nothing about what is going in. And finally, if you have the modality out and the home network is defined, I only am creating profiles for the home network, and I only care about the stuff going out. This is crucial for filtering out a lot of the traffic that you don't want to see. For example, if you are looking at infected computers in your network, this is a mod you want to see, and it's going to be much, much faster than analyzing everything coming from the internet. So now, Kalipso.
And now we're back to Kalipso interface, and I will tell you about the background. So, Kalipso is written in JavaScript code, and as we execute our JavaScript code in the console, we are using Node.js cross-platform environment, JavaScript runtime environment. And the main reason why we use JavaScript is because of these two libraries, blessed and blessed-contrib libraries. Those are high-level terminal libraries with a lot of widgets, colors, dashboards, scrolling, everything. And I will show you later. And to fill the information in these dashboards in my interface, we use redis open source in-memory data structure store. So when slips analyze the pickup, all the analyzed information is stored in redis database. And what I'm doing, I'm retrieving this information and put them in widgets. So this is blessed library. This is all in the console. You can see a lot of colors, moving boxes, everything. And actually, blessed-contrib is an extension of blessed libraries, but it has more widgets, let's say, like maps, movable graphs, stack bars, and everything. So now a little bit more about redis. So redis is in-memory key store, so it means that it stores data as a key and the value, and there are different types of key and values like strings, bitmaps, hashes, lists. And what I saw from slips, it mostly uses hashes, sets, and sorted sets. So this one, and this. This is the actual example of the key from the database. So we can see the profile, IP, and the time window. This is information I'm showing in the hotkeys widgets. For example, if you look destination ports, client UDP established, it means that when our computer is a client, we will see the amount of data sent to destination ports using UDP protocol. And this is a key, and actually this is a string. And sleep stores this string as a JSON. So what I'm doing, I'm reading the value of this key as a string, but then I'm parsing the string to a JSON, and then it's easier for me to read as a key and value.
Yeah, and this is only an example, right? Like there are like 50 or 60 more features in each profile that we know.
So now we are back to the interface. So this is the main board, and the main widget in the main board is a tree. The tree consists of profiles and all the time windows where this profile communicated. Yeah, those ones. And we can see there are some right highlighted profiles and APs, profiles and time windows. It means that there was some detection in this profile. Next, when you click on the profile and time window, there will appear a timeline on the left. The timeline is a combination of flows from conf file in a Zeek, and almost for each flow, right? Almost for each flow, we have the interpretation of this flow from other files, for example, from DNS. So we can see the domain name and other extra information that can understand the situation.
Yeah. And even if there is not, right? If you have a flow there that looks like going to port 80, but there is no interpretation of HTTP because maybe it's not, you can have an alert. Say, hey, there's something going to 80, but it's actually not HTTP, right?
Now the upper widget is IP info. This IP info represents the information of the company, of the country, geolocation, and the VirusTotal information. So if you click on the IP in the profile in a tree or on the timeline on destination IP here, for example, you will see the information about this IP in this widget. The next widget is evidence. Evidence will have information only if the profile and the window are red in the tree. So evidence is a support of the detection. For example, in this example, we see the port scan type. It means
yeah, in this case, like the port scan is an example, right? But we are telling you here, hey, there is a horizontal port scan, which means one port and a lot of IPs. This is something you should take care, right? But it can also be like vertical port scan, right? Like one IP and a lot of ports, or it can be some exploit detection, or it can be anomaly detection, right? So it's all the supporting evidence and it's telling you, hey, this is something you should take care, right?
And the last one is a help menu. This is a lower widget. It shows what other widgets are in the interface, what hotkeys you can use. And the first hotkey is e-hotkey. This is when your computer acts as a client, and you can see the amount of data sent from your port to the TCP or UDP protocol. And we have histograms for established and not established connections. And on the left, we have logarithmic scale bars that can give us quick overview where the amount of data is the largest.
Yeah. In that case, for example, you can see that there are established connections using that source port 5165, but there are a lot of them, most of them. So it's like why your computer is using this unique UDP port, source port to connect to others. Because remember that every new connection, you should change the source port, right? So this is something that is taken into account for telling you what's happening.
The next hotkey is a C hotkey. Again, your computer acts as a client, and you can see the amount of data sent to this destination IP using TCP or UDP protocol. Again, you have histograms for both established and not established connections, and the bars on the left. Next is P hotkey. P hotkey again is when your computer acts as a client, and you can see the amount of data, amount of packets, flows, and bytes sent to a destination port using TCP/UDP connection or protocol, and you can see again histograms for established and unestablished connections. The next one is N hotkey. Your computer acts as a client, and you can see the amount of connections to the destination port in the destination IP.
Yeah, so this is very important when you're looking at the traffic because it's super hard to find this by hand. You cannot go to a beacon and say, oh yeah, look in here, there is an anomaly because of the amount of destination ports sent to this IP, it's too much or too less. So these are the ways to look at the traffic from different point of views. It's like established connections, but also not established connections, which is very important for all the attacks. Most attacks do have not established connections. And then you have UDP and TCP, and of course you have ICMP, and you have an IPv6. And then you have the destination IP and the ports and the source port. And all of these ones are acting as a client But we also have these ones when you're acting as a server, which means who is attacking you and how is attacking you. So this is why analyzing the traffic is so hard, and it's so hard to get the complete picture of what's going on here. No tool can give you this super easy, no?
And next is empathy. This is the map, and the map shows all geolocations for destination IPs that we met in a timeline.
And finally, the edge hotkey is for this very large table about the behavioral. This is something that is quite unique in Stratosphere. We created those letters like 4 years ago, and the idea is that we are going to be putting in there the tuples, the out tuples of your connections. Every time you connect to some destination IP and destination port, we put all the flows together. And then the second column is showing you the behavior. I will show you now what is the meaning of the letters, but this is telling you, hey, this is non-periodic, this is too fast, this is too slow. And then the third column is the organization that owns the IP, then they have the country, and the last 4 columns is the VirusTotal IP. Anyone here is using VirusTotal for this? Searching? There? Other people? No? There? So VirusTotal is a service bought by Google that is having a huge amount of information about the security of IP, of domains, and malware, and files that you can upload, and it's checking. So it's a huge source of information. And in there you can see the column called URL is the percentage of malicious URLs that were registered, hosted on that IP. Then we have down, which means the percentage of malicious files that were downloaded from this IP. Then we have the percentage of malicious files that inside the text reference this IP. And last, we have the percentage of malicious files that are communicating with this IP. So this is giving you a huge amount of information very fast. As far as we know, few tools can go to VirusTotal and extract this information like this. Actually, if you remember the demo we were showing you before, maybe we still have it here. Yeah, in here you can see that the IP address we were talking about, the one from Indonesia, has 0000, which means it's not detected at all in VirusTotal. It's clean, it's benign, it's normal. And the rest of the IPs that belong to Google, all of them, they have some detection in VirusTotal. This is one of the most difficult problems in security. Like all the IPs from Google and Apple and Cloudflare and Amazon are being used by malicious software, so they are being flagged. But of course, a lot of these IPs are just Google, right? Like 8888, this is the Google DNS server, right? And it's have more detections than the malicious IP. So this is very hard to come by. Any automatic tool will tell you, hey, yeah, that's a huge detection. You just should block Google, which is not a good idea, right? So the people is putting this in white lists and black lists and say, no, Google, never block Google, stuff like that. But it's not that we are learning about it, right? So what we are trying to do here is to balance all this information and realize that actually this IP from Indonesia, that by the way is still alive and this is a real malware for Android, it's actually so new that still is not well known by the community. So it's not in VirusTotal yet. We will see what this is going through, right? So, a little bit about the behavioral letter so you have an idea what's going on. Remember I was telling you, every time your computer goes to a destination IP, imagine the Google, I don't know, email servers, and then you go to the port 443 because you are going to Gmail using the protocol TCP. Every time you, for example, click in Gmail, there is a lot of packets going on, and these belong to a flow. And then you click again for another email, so you have another flow, and then another flow, and then another flow. So we get all those flows together coming from you, going to Google, for example, in the port 443 TCP. This is the aggregation we are doing. All the flows that have those keys, we get together. And now, for each flow, we extract 3 features. The first one is the size of the flow. The second is the duration of the flow, and then we compute something we call the periodicity of the flow. Of course, this is not inside the flow, so the periodicity is computed like this. Every 3 flows, we have the difference of the time between the 3 flows, that is the first level time difference, 20 minutes in this case, And then we do the second level time difference, the difference of the difference. And when this number is 0, and if you divide it is 1, 20 over 20 is 1, then this is telling you, hey, this is actually quite periodic, right? And then we can measure these last 3 flows, how periodic they were. Now we have periodicity, we have size, and we have duration, okay? 3 features. Yeah. And each of these 3 features, what we are doing is a discretization. We are splitting all the range of values in 3 places. Now we can say that your flow is small, or medium, or large, and also your flow can be short, medium, or long in duration. And the periodicity, we are splitting, and we say, hey, you are strongly periodic, weak periodically, weak, non-periodic, strong, not periodic, or no data, because remember, we need 3 flows, so if there are no 3 flows, we don't have data. We put the letters, and now, look at the example here, you can see that the letters are telling me, hey, your flows are very periodic, they are short in duration, and they are huge in size, for example. In the meantime, between these letters, we put a symbol, and that symbol is giving us an idea of how fast this is happening. Yes, you are periodic. You are periodic every 1 day or 1 second. So this symbol in the middle is telling you, yeah, this is periodic and fast, this is periodic and slow, this is huge and slow and not periodic, right? So this is the type of behavior that we can put later in an algorithm to detect if you are malicious or not. And this was the first technique used by Stratosphere, using some Markov model change to know if you are in a command and control behavior channel or not, right?
Now we will talk about some problems we face during the use of blessed and blessed-contrib library. It has some limitations. For example, if I have several widgets on my screen, and I have to scroll 2 of them at the same time, but I can focus only on 1 widget. So if I'm pressing key down, only, for example, the widget with parts on the left will scroll down, but I want 2 of them. So what I had to do is to, let's say, to implement fake scrolling, which means that if I detect a key press down, it means that I'm updating the whole data in both widgets, and same happens with the up arrow. If I detect a key press up, I have to update the widgets again, so I'm scrolling up.
Yeah, and also this is putting in the position that we found many situations where the library is not good enough, and we are trying to make it work in some different ways, right? Oh, the colors cannot be managed in this way, right? Or the scrolling is not good enough. So there are many implementations at the end in there. So that's, if you want to install it and try, please go there. It's already in GitHub. We are trying to put as many features as possible. We are adding new things all the time. So please try it, download it, put your pickup, put your computer or whatever. Tell us what's going on, tell us if it's working, if it's not working, if it's good, if it's bad, because we have our own team for asking for the features, but maybe there is something more that you want to go and try, okay? If anything, you send us an email or you put some issue request in GitHub, and we are going to do our best to solve it. So that's it. Thank you very much for staying. You can contact us in there. Yeah, that's it. Thank you very much.
Thank you.
Yes, you are ready for questions.
Okay, so Sebastian and Camila are ready for questions if you have any, and I will have them with bringing the microphone so that all we can hear. Okay, it seems like everyone has a question.
You want to see the code, not yes?
Okay, there is one question. Okay.
Why have you decided for blessed library?
Good question. So the first idea was that we want an interface that is portable. So we didn't want a web interface or something that is super complicated to install, we want the people to just download, press a key, and use it, right? So there were some restrictions in there. The first idea was to use ncourses, right? Because it's a standard library for terminal, and we're looking at ncourses that we love it, and it's beautiful. And then we found that there was this improvement. Actually, that's why it's called bless, you know, course on bless. It was like, oh, look at this one. They were implementing many more features faster and with more resolution, specifically the resolution. So you can put images and stuff that is super good. So we say, oh, it looks good, it's in the console, we can run this in any Mac, Windows, Linux, no issue, no installation of something like ports or nothing. We try, we like it, yeah, and that's it.
Yeah, and that was this, yeah, but.
And JavaScript, right? Who doesn't love it? Other question? Traffic, malware, the modules. We have some of the malware, the modules developer here, so we can ask them questions on the modules. Now let's wait. Thank you very much.
Thank you very much for your talk.